Today, we're going to talk about chemical formulas and nomenclature. Nomenclature is just a fancy name for naming. So we have two main types of bonds that we are dealing with in the first year of chemistry, ionic and covalent. Ionic, composed of ions. Covalent, cohabitate, so they are sharing caring bonds. So ionic, we have electron transfer to create electrostatic attraction. That electrostatic attraction is kind of like a magnet, positive negatives pulling together to create that chemical bond. Okay. This is always a fixed ratio of elements in simplest form. To make the formula from the name, you would have to do a crisscross. We'll go over that in a minute. For naming, you name the cation first, then the anion, and change the ending of the anion to "ide" unless it was already changed from being a polyatomic. And ionic bonds, sometimes we'll see Roman numerals in the names because the transition metals can have a different charge, but they are still your cations, your positively charged ions. Covalent, cohabitate, so they're all in that non-metal area of the periodic table, and their ratio of atoms are dependent on the structure. So you can have carbon monoxide or carbon dioxide. They are both molecules of carbon and oxygen, but carbon monoxide has a 1-to-1 ratio of atoms. Carbon dioxide has 1-to-2. So you're always going to say what the name is to determine their ratio. Okay. You name the first element with its prefix, the second element with its prefix. First element, like in carbon monoxide, we don't have to say monocarbon monoxide. You always assume the first one is mono if it doesn't say. Carbon dioxide, again, we don't say the mono for carbon, but we would say it for the second element. Carbon monoxide, carbon dioxide, di-2. So sometimes we have these diatomic molecules, okay? And that just means a 2-atom molecule of the same substance. So all these Brinkelhoffs are there. Bromine, when he's by himself, he will form a 2-atom molecule. I call that with his twin. Okay, so when he's in a molecule with other people, he can have 1 bromine, 2 bromine, 3 bromines, however bromines he needs to create the proper ratio. But when he's sitting there by himself, then he would have his 2 with them. So, state the name and chemical formula for a compound composed of oxygen and aluminum. First thing, figure out it's ionic or covalent before you decide what the rules are. Oxygen, non-metal. Aluminum, okay, that guy is on the staircase. So if you're on the left of the staircase, you're a metal. If you're on the right of the staircase, you're a non-metal. That's why they cohabitate right there, okay, and form covalent bonds. But if you have a metal and a non-metal, they're on opposite sides, so they form ions. Aluminum is right here. He is touching the staircase. So technically, if you're touching the staircase, you're a metalloid, but there's a lot of arguments out there with what ones are actually metalloids or not. Aluminum is definitely not a non-metal. So we're either going to put him on the metal side or the metalloid side, but that is going to give him a positive charge, and he's not a non-metal. What were the rules again? Ionic bond is with ions, so a positive and a negative, creating that electrostatic attraction. Covalent, their rule was all nonmetals. So it cannot be covalent because aluminum is not a nonmetal. So he's going to have a positive charge, and we can leave the arguing to the metallurgists on if he is a metal or a metalloid. But since he's positive, he is going to go first. He's in group 13, so he has a +3 charge. Oxygen is in group 16, so he is 2 away from being a noble gas. He needs to add 2 electrons, add anions. Okay, we always add electrons for our anion. So he's 2 away from being a noble gas. So he's 2 minus because electrons are negative. And what is that? Group 16, always a 2 minus charge because they have 6 valence electrons and they are 2 away. Now, how do we find the formula? This is called the crisscross. We take the absolute value of the charge and put it with the other elements. So the 3 becomes a subscript of oxygen, and the 2 becomes a subscript of aluminum. The subscript is how we get the ratio of the atoms. So there are 2 aluminum atoms for every 3 oxygen atoms. Every time for aluminum oxide, ionics have fixed ratios. Covalents can be different depending on their structure. But aluminum and oxygen, when they're put together, always 2 aluminums for every 3 oxygens. All right. And what else did we need? So we got the chemical formula. That was our model representing the ratio of elements, and that's called the chemical formula. Make sure you use proper capitalization, or you could actually be giving me a different compound than what you expected. And now we need the name. The name. Name the anion, aluminum. Name the anion, oxygen. Change oxygen's ending to "ide." Aluminum oxide is the name. Right, next guy. How many of each element in this binary compound? We did that. 2 aluminums is 3 oxygen. Binary compound, 2 element compound. State the name and chemical formula for a compound composed of oxygen and magnesium. All right, well, we know oxygen already. Non-metal, -2 charge because it's 2 away. Magnesium, capital M, lowercase g. On your SOL, the names are on the periodic table, so use that to your advantage. Magnesium is in group 2. So he has 2 valence electrons. He has 2 extra electrons he wants to get rid of. When he gets rid of those 2 negatives, he becomes 2 positive. We have an ionic situation here because we have a plus-minus bond. Crisscross to find the formula. Start with the positive, then the negative, add ion first, and then we crisscross. 2, 2. When we rewrite, we don't put the charges on our chemical formula because it's about the ratio of the atoms. And so those subscripts tell us the ratio. It's an ionic bond. What's special about ionic bond? It has a fixed ratio in simplest form. 2 and 2 are both divisible by 2, so it's not in simplest form right now. Now, magnesium 1, oxygen 1. It's in simplest form. There's 1 magnesium for every 1 oxygen. And when we write the chemical formula, we would just write MgO. We don't have to write the ones. What's its name? Name the cation, magnesium. Name the anion, oxygen. Change the anion's ending, "ide." Magnesium oxide is always going to have a 1-to-1 ratio because ionics have a fixed ratio in simplest form. And again, it's a binary compound because there's only 2 elements in it. Nitrogen trihydride formula. Okay, I didn't put the warning up here, still the same. Always, always, always figure out if it's ionic or covalent. Nitrogen is a nonmetal. Hydrogen is a nonmetal. Even though he's way over on the left, he is still a nonmetal. How else do I know it's covalent? Besides being all nonmetals, I see prefixes. We only use prefixes in non-metal covalent bonds. All right, nitrogen is the first element. Hydrogen is the second one. Nitrogen does not have a prefix. What was the rule? If there's no prefix, it's mono. We just don't have to say it. So we have 1 nitrogen. The hydrogen has a triangle, 3 sides, N1H3. So when we're answering the question, there is one nitrogen in every nitrogen trihydride, otherwise known as ammonia, which is a base. Every time. This is its ratio. Nitrogen trihydride always has one nitrogen and three hydrogens. However, there are other chemicals that could combine in a different ratio because it's covalent. When we write the chemical formula, NH4. So you might see it like this. This is still one nitrogen and three hydrogens. Still a binary. This is a binary molecule because this is sharing. The nitrogen and the hydrogen are sharing electrons here, creating a neutral molecule. No ions in this guy. What is the proper chemical formula for chromium 5-sulfate? So in this case, they gave us the name, but they gave us this number here. This is a Roman numeral. If you see a Roman numeral, it means it's a transition metal. Chromium, Cr, has a charge of 5, not a number of atoms. It's always based on the charge, because the charges change. We always have the fixed ratio, so we don't need to write down the fixed ratio in the name. Okay, it's not covalent. What type of 5? Positive or negative? Chromium's a metal. Metals are typically positive, so it's a cation. You also know this because it's listed first. We know it's ionic, which means it has to have a positive component and a negative component. The positive's always first. Sulfate, hey, that does not have an "ide" ending. This is not a binary. Sulfate is a polyatomic ion, many atom ion, and that's SO4 with a 2-. When we're dealing with these crisscrossing, polys get parentheses, and then we crisscross. Otherwise, we can put this 5 in the wrong spot if we did not have those there. So Cr2, SO4, 5. Chromium 5 sulfate is its name. Chromium and sulfate combine together with a positive-negative bond. That is ionic. However, sulfate, the actual polyatomic ion, is all nonmetals. So he is covalent. So you can have covalent characters or covalent sections, but still an overall ionic bond. What else can we gather from here? How many of each element are in one formula unit? So this is a formula unit. We have 2 chromiums. And, oh, how do we figure out these guys? Parentheses, just like math class, we can distribute. 5 times 4 gives us 20 oxygens. And 5 times however many sulfurs. How many sulfurs are there? It doesn't show. It's a 1. 5 sulfurs. So there's 2 chromiums, 5 sulfurs, and 20 oxygens in chromium 5 sulfate. How many of each ion? Ions are just what you see with the crisscross. There are 2 chromiums and there are 5 sulfates when we're looking at each ion. So it depends on if they want ion or each element. How many of each element are in iron 2 chloride? Oh, Roman numeral, so right there, I know I have a transition metal, which means I'm not all nonmetals, so I have an ionic bond. Okay. I'm going to start with the positive. Iron is capital F lowercase e with a charge of 2, positive 2, cation. Always starting with that cation, that positively charged ion. And then chlorine. Chlorine is 1 away from being a noble gas. He needs to add 1 electron, adds for anions. We always add electrons for anions. So he has a 1- charge to be that anion. Chlorine is in group 17. Everybody in group 17, that's that column right next to the noble gases, otherwise known as the halogens, always have a -1 charge. This is ionic, so I'm going to crisscross. Fe1Cl2. We have 1 iron for every 2 chlorines, fixed ratio because it's ionic. My actual model of the ratios would be FeCl2, just without the 1. That is the chemical formula. And that's all we have. Have a good day.